Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a square minus b square equals to 49, and we solve this problem for all the values of a and b. So we solve this problem for the positive integer values of a and b. So first we need to focus into the left hand side, and you see here this is very famous algebraic formula, and we know about that a square minus b square is equals to a minus b times of a plus b is equals to 49. So you see here in the left hand side we have these are the two factors are multiplied by each other, but in the right hand side we have only one factor, that is 49. So we need to find any two positive integers whose product becomes here 49. Okay, the possibilities are 1 multiplied by 49 is equals to 49, and 7 multiplied by 7 becomes here 49. So here we have there are these two possibilities in which we get the product of two positive integers becomes 49, and here in the left hand side we need to make the relation between these two values. You already know about that the first factor is always less than or equals to the second factor. Okay, so here we divide this equation into the two cases, and our first case is in the first case we compare both of these two factors with 1 and 49, and it will be written as a minus b is equals to 1 and a plus b is equals to 49. And here we write the second case, and in the second case we again compare both of these two values with these two numbers, and it will becomes a minus b equals to 7 and a plus b is also equals to 7. So we have these are the two cases, and we need to solve both of these two cases, and we easily get the values of a and b. And now here in order to solve these, first we solve case number 1, and here we call this is equation number 1 and this is our equation number 2. And now for the values of a and b we need to first sum up equation number 1 and equation number 2. So when we add both of these two equations, you see here a and a are be the similar terms, and when we add a plus a it will becomes 2a. This is negative b and positive b are cancelled out by each other, and it is equals to 1 plus 49 becomes here 50. And now for the values of a we need to remove this 2 from here, and for this we divide both of the sides by 2. So this 2 and this 2 are gone, and we get here our a is equals to, here we need to cancel these two terms, and we get 2 times 2 becomes 4, and we carry 1 and we get 2 5s are 10. So here we easily get the value of a is equals to 25, and you clearly see here 25 is belongs to the positive integer. Okay, this is the first value of a, and now here in the same pattern we need to find the value of b. So for this we substitute this value of a into the equation number 1 or equation number 2. So we substitute this value into the equation number 1, and here our equation number 1 is implies that so we put this value of a in equation number 1, it will becomes 25 minus b is equals to 1. And here we move minus b to the right hand side, and we move plus 1 to the left hand side, and it will becomes 25 minus 1 is equals to b. And we obtain 25 minus 1 becomes 24 is equals to b, and here you again clearly see that b equals to 24, and 24 is also belongs to positive integer, and this is the value of b which we get here from first case. And now in the same pattern we need to focus on second case. So this is our second case, and in the second case we call this is equation number 3 and this is equation number 4. And now here first we add equation number 3 and equation number 4, and we obtain this minus b and plus b are cancelled out by each other, and we get a plus a becomes 2a equals to 7 plus 7 becomes 14. And now for the values of a we need to remove this 2 from here, and for this we divide both of the sides by 2. These 2 and 2 are gone, and we get here 2 times 7 becomes 14, and here we easily get a is equals to 7, And again you see that this 7 is belongs to positive integer. This is the value of a which we get here from the second case. And now we substitute this value of a into equation number 1, into equation number 3, or equation number 4. Okay, so but we substitute this value in equation number 3, and equation number 3 is implies that this will becomes here 7 minus b is equals to 7, and here we move minus b to the right hand side and we move 7 to the left hand side, and it will becomes here 7 minus 7 is equals to b. So you see here 7 minus 7 becomes 0, and we obtain the value of b is equals to 0. This is the value of b, and finally we obtain there are two solutions of the given equation, and these two solutions are a b is equals to, the first solution is 25 and 24, and the second solution is 7 and 0. So here we need to verify both of these two roots, and we check that is these two roots be the solutions or extraneous root. So for verification we need to copy down given question statement. Here it is a square minus b square equals to 49. And now first we verify the first solution, and from here we have the value of a is 25 and the value of b is 24. So when we put this value of a and b into this equation, it will becomes here 25 square minus 24 square is equals to 49. And we know about that 25 square becomes 625 and 24 square becomes 576 is equals to 49. And here you see that 625 minus 576 is equals to 49 equals to 49. So this shows that both of the sides are equal when we choose a equals to 25 and b equals to 24. And now in the same pattern we need to verify the second values of a and b, and here we choose a equals to 7 and b equals to 0, and we substitute these two values into the given question statement, and it will becomes here 7 square minus 0 square equals to 49, and you clearly see here 49 is equals to 49. This shows that the second solution is also satisfied our given question statement, and both of the solutions are satisfied our given question statement. And this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.